Have you ever just tapped a like button on your phone and thought, how did this little thing even get here? It seems so simple, right? Just a little heart on a screen. But behind that one tap is this incredible journey, one that involves a whole team of people, some really powerful ideas, and yeah, some seriously cool technology. Today, we're going to follow that journey step by step, from a simple idea all the way to the palm of your hand.
So here's our roadmap for this trip. We're going to start with the why. Why did software development have to get so much faster? Then we'll get into the nitty-gritty. How the code actually gets written, how it's packaged up, and how it's launched for the whole world to use. After that, we'll talk about what happens after the big launch, because the story doesn't end there. And finally, we'll see where you might fit into this whole picture. Sound good? Okay, let's get into it.
You know, it all really boils down to one thing: speed. To stay alive in today's market, businesses have to get new ideas and features out to their customers fast and reliably. In the old days, getting a single new feature out the door could take months, sometimes even years. And in the modern world, that just doesn't fly. The whole game had to change.
Okay, so check this out. The old way of building things was what we call a monolith. Imagine one giant, tangled ball of yarn. Everything is connected to everything else. If you wanted to change the color of just one tiny thread, you had to unravel and redo the entire ball. It was slow, it was super risky, and honestly, it was a huge pain. The new way? Microservices. It's like breaking that giant application into a bunch of tiny, independent Lego bricks. Each little brick does one specific job. So you want to update the like button? You just swap out that one little Lego brick. You don't have to touch anything else. It's faster, safer, and way more flexible.
Now, this new way of building software also demanded a new way of thinking. And that's where these two big ideas, Agile and DevOps, come in. Agile is all about breaking down the walls between the business folks and the developers, getting them to work together in these short, focused bursts. But DevOps takes it a step further. It asks, hey, what about the people who have to actually run this stuff in the real world, the IT operations team? DevOps brings them into the loop from day one and uses a ton of automation to make the whole process, from writing code to running it, a smooth, predictable assembly line. It's a massive cultural shift.
All right, so with this new mindset and our Lego brick architecture ready to go, it's finally time to build our feature. This is where a developer sits down and actually brings that idea to life with code.
So a developer's day isn't just them in a dark room typing like crazy. First, the whole team plans together. They have quick daily meetings to figure out what needs to get done and break it down into small, manageable pieces. Then, the coding happens using languages like Python. But here's the really crucial part. Every single change they make, no matter how small, gets saved and tracked using something called a version control system.
So what on earth is a version control system? Honestly, the best way to think about it is like a time machine for your code. Seriously, it keeps a perfect history of every single change, who made it, and when they made it. It lets dozens of people work on the same project at the same time without tripping over each other. And the biggest, most popular one out there by far is called Git.
Let's make this super simple. When a developer is working, they first make a Git commit. You can think of this like saving a draft of a document on your own computer. It's a snapshot of your work just for you. Then, when you're ready to share that work with the rest of the team, you do a Git push. That sends your saved draft up to a central shared place where everyone's work gets combined.
Okay, so our developer has written the code. It runs perfectly on their laptop. They're feeling pretty good. But this moment leads to one of the most famous and most dreaded phrases in all of software. But it worked on my machine. How do you make sure that the code that works for one person also works for everyone, everywhere?
The answer is the Docker container, and it's kind of like a magic shipping box. Inside this box, you don't just put your code, you pack up everything that code needs to run. All the settings, all the libraries, the whole shebang. This self-contained box can then be moved from a laptop to a test server to the cloud, and the code inside will run exactly the same way every single time. It is the ultimate cure for the "it works on my machine" problem.
Now, it's really important to get the difference between an image and a container. Just think of a cookie cutter and the actual cookies. The Docker image is the cookie cutter. It's the blueprint, the template. It doesn't do anything on its own. The Docker container is the actual cookie that you punch out using that cookie cutter. It's the real running application. You can use that one image, that one cookie cutter, to create thousands of identical running containers. Okay, so we've got our feature all packed up in its neat little container. That's great, but a popular app might need to serve millions of users all around the world. You can't just run one container. You need to run thousands of them all at once. How on earth do you manage that kind of scale and complexity?
Well, you do it by applying another one of those key DevOps ideas, infrastructure as code. This means instead of having someone manually click buttons in a web console to set up servers and networks, you define your entire environment in code files. You literally write code that describes your servers. This makes everything repeatable, automated, and way less prone to human error.
And the master conductor for this whole orchestra of containers? That would be Kubernetes. If you have thousands of containers running, Kubernetes is the one telling them all what to do. It figures out which server each container should run on, it automatically replaces them if they crash, it scales them up if traffic gets heavy, it basically manages the entire chaotic performance for you.
So, how do all these pieces connect? How does a developer's Git push end up as a running container managed by Kubernetes? It happens through something called a CICD pipeline. This is the fully automated assembly line of modern software. The CI part, continuous integration, grabs the new code, builds it, tests it, and packages it into one of those Docker images. Then the CD part, continuous delivery, takes that finished image and automatically deploys it out into the world on Kubernetes. This whole process, from a developer saving a file to a feature being live for millions of users, can happen automatically, safely, and sometimes in just a few minutes. It's amazing.
And scene. Our like button is now live for everyone to use. Success. But hold on. The journey is far, far from over. In a lot of ways, this is where the real work begins. Now the team has to actually operate this thing and keep the lights on. This kicks off this constant living feedback loop. First, the team is always monitoring the system, watching its health. If they see that tapping the like button is suddenly taking 5 seconds instead of a fraction of a second, that's an incident. They'll then respond to fix it right away. But they don't just stop there. They dig deep to find the root problem that caused the incident in the first place. And all that information feeds directly into the next step, improving the system so it's stronger and more resilient for the future.
And that improving part isn't just some vague idea, it's actually a formal part of the process called a retrospective. At the end of a cycle, the whole team gets together. No finger pointing, just talk about what went well, what could have been better, and what they're going to change next time. It's this structured way to constantly inspect and adapt, making sure the team, the process, and the software itself are always getting better. And just like that, the end of the journey loops right back to the beginning.
So we've followed this incredible automated journey of a single feature. But it is so important to remember that none of this is run by robots. This whole system, this entire process is made possible by a diverse team of really smart, collaborative people.
I mean, look at this list. It really is a massive team effort. You've got the developers writing the code, the DevOps engineers building those slick automated pipelines, the data scientist analyzing all that feedback to see if people even use the new feature, the security teams making sure everything is safe, and of course, the product managers who had that initial idea for the feature in the first place and guided the vision.
So if you're listening to all this and wondering, okay, where do I fit in? It's all about connecting your own skills to this bigger process. Just understanding this full journey, from idea to code to container to the cloud, is an incredibly powerful skill all on its own. Your resume becomes a story of how you can help solve these kinds of fascinating, complex problems, no matter which role you're aiming for.
So that's the journey. From a simple idea, guided by philosophies like Agile and DevOps, and powered by amazing tools like Git, Docker, and Kubernetes, all the way to a feature in the palm of your hand. This is how modern software is built. It's a powerful, fast, and collaborative way to create things. And it really just leaves one question. What will you build next?